Startup Exchange discussion. As I said earlier at the beginning, at MIT, we don't just do research. We do produce companies, companies that will take the research findings to their prototype to the market and to make an impact. So that's why we have the next session about Startup Exchange. And my colleague, Katarina, will moderate the session, and I'll just let her take over. Katarina?
Thank you, CJ, for the kind introduction. Hello, everyone. I'm delighted to be here with you today to present the Startup Lightning Talks. We've invited 2 startups for you to meet. Each one will present for 10 minutes, followed by 5 minutes of Q&A. So please keep sending your questions through the Q&A feature. But first, I'd like to take a couple of minutes to tell you about our program. So Startup Exchange was created within MIT Corporate Relations to support MIT-connected startups to grow, expand, and solve the world's great challenges. And we do that by fostering collaboration and partnerships between startups and industry, such as corporate members of the Industry Liaison Program, as many of you are, and the MIT Innovation Ecosystem. So the startups we support, all of them must have a strong connection with the Institute. This connection might come through the founding team, the technology, and some are also affiliated to our MIT peers who vet and support the startups throughout the year. Today, our program has a network of close to 1,000 startups virtually working in any sector. They also may be located in any country. And we typically start working with them when they have a technology or a product that is ready to be tested or used in real environment. So everything we do at Startup Exchange is to expose and connect startups with the industry in a highly curated way. And we also provide learning opportunities to both parties. This includes launching calls for startups based on corporate's own challenges and strategic priorities, facilitating one-on-one meetings between them, and hosting different kinds of events, such as demo days, speed networking events, pitch sessions. And the learning opportunities typically come through via workshops that we co-organize with our MIT peers. So at the end of the day, the goal of all these activities is twofold. On the one hand, help startups scale, pivot, expand your customer base, and in case of corporates, help them learn as well about the most recent technologies, help them expand their portfolio or even create new business lines. And this slide features a very small sample of the success cases we had to date that usually include proofs of concept, pilots, joint R&D, and even acquisitions. This is Startup Exchange in a nutshell. If you'd like to learn more about our program, please do reach out. I'd be happy to answer any of your questions. And now, without further ado, it is my pleasure to introduce you to Prabhu Rao, President and CEO of IVIS, who will tell us all about the technological solutions the company is working on and how you can get involved. And again, please do send us your questions through the Q&A feature. Thank you.
Well, thank you, Ken. Thank you, Katrina. Thank you for giving us the opportunity to present at this event. Our affiliation with MIT is through Chris O'Brien, who's an alumni of MIT and a shareholder of one of the IVIS Group companies. I'd like to take this opportunity to provide you an introduction to a company, IVIS Adsorption Inc. And the mission of this company is to enable a sustainable and a circular economy. We engineer, manufacture, and service most advanced gas condition and purification products that enable a sustainable and circular future for the planet. So think of the company as a company that produces products that are like the jeans and shovels of the clean tech future. Our focus is in gas conditioning and gas purification, and these are based on our two core technologies, temperature swing absorption and pressure swing absorption. The TSA technology is used in our gas dryers. We use them to dehydrate various types of gases. We started with air dryers many years ago, and then we transitioned to doing methane and renewable natural gas dryers. The methane dryers are used in compressed natural gas stations in North America, and more recently we've been deploying these dryers in biogas upgrading facilities or renewable natural gas generation sites. And now we are looking at hydrogen, whether it's green hydrogen or other sources of hydrogen. Those generation pathways require hydrogen drying for either fuel cell application or industrial applications, and we deploy hydrogen dryers for those sites. Our pressure swing absorption technology is used to separate a mixture of gases in many applications in the clean energy industry. The core of our knowledge is in the absorption materials themselves. So we select and design absorbents that are used to separate gases in a pressure swing absorption system, and our expertise is in actually layering the different types of absorbents and making sure that the right purity and recovery is achieved in the process. So we've used this PSA technology extensively in many areas. PSAs in general have been around in the oil and gas industry for a long time. What is unique about the IBIS technology is this combination of our knowledge in absorbents and our very unique, what we call a rotary valve, a fast cycle PSA. And to explain that difference between a conventional PSA and a rotary valve PSA, there are two images on the slide. The image that you look at on the left is a typical conventional PSA. So it involves, in terms of PSA purification, what you typically do, depending on the gas mixtures and the purity that you need, you have multi-stages of purification. And a conventional PSA typically has 3 or 4 stages of purification. And you see these tanks that are very large tanks that are filled with adsorbents. And all these tanks are connected through a lot of plumbing and valving, and these valves are used to navigate the flow between the various tanks. What that does is it obviously makes the plant size quite large. It's complex, and they have numerous switching valves, and typically the failure modes for these PSAs are the valves. What we've been able to do is replace all the plumbing and the valves by what is called a rotary valve. Imagine 2 metal discs that are rotating, and there are lots of channels that are machined within those discs. And as these discs rotate, we use the channels to transport the gases between the various cylinders. So what that's done in terms of advancing the technology, the fast cycle PSA makes these vessels about 10 times smaller, and also eliminates all the valving and the plumbing. So you basically miniaturize the industrial scale solutions into a much smaller system, which we manufacture at a factory and ship to site. And as you're using less amount of adsorbents and less amount of metal, clearly it also reduces the cost. So we have used this technology in many markets, but over the last 10 years, a lot in the clean energy space. We've done a lot of work in renewable natural gas, more recently in many areas of hydrogen, and now we are introducing products in the carbon capture space also. What I'd like to do is the next few minutes talk a little bit about our offering in the RNG space and also the hydrogen space. So when it comes to producing renewable natural gas, the lingo that's used is called biogas upgrading. So the biogas is generated in many different applications: landfills, wastewater treatments, organic waste diversion, dairy farms. So a lot of these sites, the biomaterial is fermented, and the biogas that comes out of there has a combination of methane and CO2. And in some cases with landfills, you also have some oxygen and nitrogen and other contaminants. So what we do is we take that biogas and we use our PSA solution to separate the methane from the CO2. And that methane is called the renewable natural gas, is then either injected into pipelines or it's used for transportation fuel. So this is an area that's we've been working in this space for a while. We have about, I think it's close to 100 deployments worldwide. Just as an example of the types of projects that we are involved with, these are 4 locations. The top left is it is in Toronto. That's the organic waste diversion facility for the city of Toronto. So all the organic waste comes there, it gets digested. We take the biogas from there, we take out the sulfur or the H2S, and then we upgrade the biogas to make RNG, and the RNG is injected into the pipelines. The site on the right is this for the city of Montreal. Again, we have a very large plant there. So both the locations in Toronto and in Montreal, we have managed the construction of the site, and also we provide services to those 2 cities in terms of operating those sites. We deployed a lot of product in Europe, much smaller scale, and we have done about 40 sites in France and about 5 in Italy to date, and we continue to expand in that area. Typically, we do about 5 or 10 biogas projects per year. These are obviously sizable projects. More recently, there's been a focus on farm digesters, and the driver behind the biogas industry, the economic driver is really that the renewable natural gas that is formed, it is classified as a D3 RIN under the renewable fuel standard. So and on top of that, you can add the LCFS credits that you get. So the developers that are developing these projects take advantage of the D3 RIN value and the LCFS value, and they're able to sell that to the renewable fuel market. So we've been doing a lot of projects in the Midwest and in California. Here you're looking at basically farm digester and manure digester. So our products are called the BioStream. What we have tried to do is try to integrate the entire biogas upgrading plant in a container, so that the installation cost, the time to install, and the cost to install is minimized. And we are now deploying these products, as I said, as mostly in the Midwest of the United States. So we'll continue to work in this space. The first few years we saw a lot of activity in landfills. Then it was followed by farm and manure digesters, and now we are seeing a transition to organic waste diversion. And a lot of companies, like the big retailers like the Targets and the Walmarts and the Amazons, are looking at how to deal with their organic waste. It's a pretty significant number. I think the number is 30 to 40% of all food product made in the US is wasted. So there's a significant amount of biosource, and the idea is to take that and create renewable fuel from that. And so we're playing I think a significant role there. So now let me transition to the hydrogen space. There was a lot of discussion today about hydrogen. Green hydrogen is, there was presentations about green hydrogen before, and there'll be a presentation after mine about this. Green hydrogen is a very good mechanism to make hydrogen through electrolysis, but a lot of the economics behind green hydrogen depend on the cost of the electron. So if the cost of power is low, green hydrogen makes a lot of sense. But if the cost of power is high, like in many regions of the world, people are looking at other sources of low carbon hydrogen. And we've been working in a number of these areas. Gasification is one, taking biosources and doing gasification, or pyrolysis. People are looking at pyrolysis of methane itself, which they separate the hydrogen, and the carbon is collected as a product and sold into the tire and the paint industry. We have done again hydrogen production from ammonia, hydrogen production from methanol. These two are looked as hydrogen carriers. So when you either crack ammonia or the methanol through reforming, they require purification. So all these various mechanisms of making hydrogen require some sort of gas purification, whether it's for industrial use or for you purify it to fuel cell grade. And we provide our PSA technology for that. We are probably engaged with most of the gasification companies around the world in terms of producing compact, small-scale PSA solutions. One area which is interesting is that there's a lot of waste hydrogen produced from industrial processes or from fuel cell systems that are producing power. And there's a desire to recover this waste hydrogen because it is low cost and then reuse that for different applications. One of the projects that we are involved with is in the Port of Long Beach. This is a fuel cell system that's on site there that produces power, but also they have a slipstream of gases that have a significant amount of hydrogen. So what you're looking at here is our PSA systems is a two-stage PSA. We take that gas stream, we purify the hydrogen, and then that hydrogen is actually sent to a fueling station on site. And the fuel cell cars and the fuel cell trucks that come from Japan or Korea or other locations, when they come to the Port of Long Beach, that hydrogen is used to fuel those vehicles so that they can then go to the dealerships. So there are many such projects that we're involved with. We have deployed about 350 PSAs in the hydrogen space over the last decade or so. And lastly, we do a lot of work in the renewable energy space, but the same technology is also used in industrial gases. And as an example, helium is a very unique commodity, and the price of helium fluctuates quite a bit. But we are involved with deploying between 4 and 5 helium projects per year in North America. And what we do is we work with an industrial gas company to combine our PSA technology with their membrane technology and produce high purity helium for the semiconductor industry or other industrial uses. So that kind of gives you a quick summary of the company. I mean, we've done work in many different areas. In terms of possibilities of engaging with us, I think hydrogen and biogas are core. We do a lot of work there, and we have commercial product that we deploy. So we look forward to any inquiries surrounding that. In terms of research and development and new products coming out, I would say carbon capture is a space that we're looking at very carefully. Our biogas product is a carbon capture product. So we use the same adsorbent technology and the same products to look at, I would say, not very large scale carbon capture, but small scale from small factories, buildings. We did a project with a partner in New York City, in Manhattan. And there's a building in Manhattan which has one of our systems in the boiler room, and they capture all the carbon coming out, the CO2 coming out of the boiler system. And then that's liquefied and sent out to a cement manufacturing plant. So there are opportunities like that where we can do small scale CO2 capture from point sources. But the more exciting thing, I think, from a development point of view is we believe in circularity of hydrogen, CO2, and methane. There was a discussion about CDR, and I think we look at it as CDRR, is carbon dioxide removal and reuse. So we are looking at combining hydrogen and CO2 to make methane that can be injected back in the pipelines. So methanization is not a new technology. It's been around for a while, but it's done at a very large scale it looks like a plant. What we are trying to do is commercialize that as a product in a containerized solution. So there's a lot of work related to heat exchangers, catalysis, adsorbents coating on metals, trying to make it almost like a fuel cell stack or an electrolyzer stack, but and that does methanization. So that's an area we are working with some universities, and we look forward to any engagement from the industry on that space. But I'll stop here and answer any questions that are there.
Thank you very much, Prabhu. We do have a few questions for you here. The first one, how do the economics compare for the various sources of hydrogen?
I would say, I mean, if you're following the hydrogen industry over the last 2 or 3 years, there's been various way of classifying the hydrogen, and interestingly enough, they've used a color scheme. There's green hydrogen, there's blue hydrogen, and there's all types of shades of hydrogen. When it comes to green hydrogen, as I said, there's been a lot of work in reducing the capital costs of the electrolyzer. And I think there's good progress there. And we'll hear more about it next. I think the driver there is really the cost of power. So if you can get very low cost of power, green hydrogen becomes very attractive. If not, then it's difficult to compete with blue hydrogen or other sources. I think people are looking a lot at gasification today. I know we engage with probably 20 companies around the world that are looking at various forms of gasification. I think there's some exciting things happening there. I feel like I think over the next 2 or 3 years, we'll see out of the various different technologies, some of them succeeding, and we can see gasification-based hydrogen being competitive. I think the only other thing I would say is that people are looking at ammonia and methanol as a hydrogen carrier. So you make green hydrogen or other forms of hydrogen and use ammonia and methanol. The economics of that are not clear yet, but I would think right now I would say green hydrogen with low cost power or hydrogen from gasifiers is probably the 2 pathways we look at.
Mhm.
And then there's obviously the traditional making hydrogen from natural gas and capturing the carbon. That's probably also one of the attractive pathways.
Mhm. Thank you. Could you tell us what's driving the biogas markets and the economics behind them?
I think the driver is the renewable fuel standard, right? So it's because of the requirements of the refiners, they have to buy a certain number of credits in terms of renewable fuel credits. So there's the RFS credits, and then there's the LCFS credits in California and some other states in North America. So a combination of the two is generating the demand for renewable for RNG. And there are some, in some locations, the utilities themselves are required to have a certain percentage of renewable natural gas in their pipelines, like in some provinces in Canada. And that's driving a demand for RNG also. So those utilities are then are able to provide 10, 15, 20-year offtake agreements to the developers. And that I think that's a strong driver.
Okay. And last question, have you done any projects in the carbon capture space, and how does your product fit in that space?
We've done a few. I think, as I said, the most interesting one that we have done, because our product is probably not suitable for carbon capture from a utility, or from a power plant, or for a cement plant, but it's more small-scale industrial and buildings. So one of the most exciting projects that we did a couple of years ago is, as I said, it's a residential building in Manhattan, and there are some legislative requirements that are driving some of these projects in Manhattan or New York. And what we did is we put in our carbon capture solution in a boiler room of a building, and we take all the exhaust gas from their heating system, and we separate the CO2 from that. And then CO2 is liquefied and taken out to a cement manufacturer who uses CO2 for manufacturing of cement. So that's one of the exciting things. It's a very unique project, and the reason why we are able to do it is because how compact our PSA is, and that's the fast cycle PSA enables you to do that. I think if the economics of that project are successful, there's demand for that, and I think obviously from a regulations point of view, the state of New York is pushing that. I think if you're successful there, I suspect that that the same regulations will be looked at probably in other parts of the world.
Mm-hmm. Okay, thank you, Prabhu. Thank you again for being with us today.
Well, thank you for giving us the opportunity.